Abu Ali al-Hasan ibn al-Haytham, known in the West as al-Hasan, was born in Basra, Iraq, in 965 CE. This was a period known as the Golden Age of Islam, a time of great intellectual and cultural flourishing. From a young age, Ibn al-Haytham displayed a keen intellect and an unquenchable thirst for knowledge. He immersed himself in the study of various disciplines, including mathematics, astronomy, physics, and philosophy. Ibn al-Haytham's birthplace, Basra, was a bustling center of trade and scholarship. It boasted a renowned library, the House of Wisdom, which housed a vast collection of manuscripts from across the known world. This vibrant intellectual atmosphere nurtured Ibn al-Haytham's curiosity and provided him with the resources to pursue his studies. Ibn al-Haytham's early education laid the foundation for his future scientific endeavors. He excelled in mathematics and geometry, which proved to be invaluable tools in his later work on optics. His thirst for knowledge extended beyond the confines of traditional Islamic scholarship. He eagerly sought out Greek and Persian texts, immersing himself in the works of Ptolemy, Euclid, and Aristotle. Ibn al-Haytham's education was not limited to formal institutions. He was known for engaging in passionate debates with scholars from different backgrounds and traveling extensively in pursuit of knowledge. This insatiable curiosity and willingness to challenge established ideas would become hallmarks of his scientific approach. Ibn al-Haytham's most significant contributions were in the field of optics. His work laid the groundwork for many scientific advancements that followed. His magnum opus, the Book of Optics, revolutionized the way we understand light and vision. This monumental work was not just a collection of theories, but a comprehensive study that combined observation, experimentation, and mathematical analysis. This 7-volume treatise, written over several years, challenged centuries-old theories and laid the foundation for modern optics. It was a pioneering effort that bridged the gap between ancient and modern scientific thought. Before Ibn al-Haytham, the prevailing theory of vision proposed by Ptolemy held that the eye emitted rays that illuminated objects. This idea was widely accepted for centuries. Ibn al-Haytham refuted this theory, demonstrating that vision occurs when light enters the eye. His experiments showed that light travels in straight lines and that our eyes receive light from external sources. The Book of Optics was a groundbreaking achievement. It was not just a theoretical text, but a practical guide that included detailed descriptions of experiments and observations. It covered a wide range of topics, including the anatomy of the eye, the nature of light, reflection, refraction, and the behavior of lenses and mirrors, and the formation of images. Ibn al-Haytham's work also delved into the psychological aspects of vision, exploring how the brain processes visual information. Ibn al-Haytham's meticulous observations and experiments transformed the study of optics from a philosophical pursuit into an experimental science. His legacy continues to influence the field of optics and vision science to this day. Ibn al-Haytham's experiments with light were ingenious and groundbreaking. He was the first to systematically study the properties of light, including its reflection and refraction. Using simple yet effective tools like pinholes, lenses, and mirrors, he conducted experiments that revealed the laws governing the behavior of light. One of his most famous experiments involved a darkened chamber with a small hole on one side. He observed that light passing through the hole projected an inverted image of the outside world onto the opposite wall. This experiment, known as the camera obscura, demonstrated that light travels in straight lines and laid the foundation for the development of the camera centuries later. Section 5. The power of observation and experimentation. Central to Ibn al-Haytham's scientific method was his emphasis on observation and experimentation. He believed that scientific knowledge should be based on empirical evidence rather than abstract theories. He meticulously recorded his observations and repeated his experiments multiple times to ensure accuracy. This rigorous approach, novel for his time, marked a significant departure from the classical reliance on philosophical arguments. Ibn al-Haytham advocated for a systematic and empirical approach to scientific inquiry. He stressed the importance of questioning everything and testing all theories through rigorous experimentation. This emphasis on empirical evidence laid the foundation for the scientific method that would revolutionize science in the centuries to come. Section 6. Challenging ancient wisdom. Ibn al-Haytham did not shy away from challenging established scientific authorities. He questioned the theories of ancient Greek thinkers, including Ptolemy and Euclid, when their ideas were not supported by his own observations and experiments. His willingness to challenge dogma and think critically helped advance scientific understanding beyond the limitations of ancient wisdom. For example, he refuted Ptolemy's theory of planetary motion, which proposed that planets moved in perfect circles around the Earth. Ibn al-Haytham's observations led him to believe that planetary orbits were more complex. This questioning of established theories paved the way for later astronomers like Copernicus and Kepler, who would eventually develop a more accurate heliocentric model of the solar system. Section 7. Beyond Optics, a Polymath's Legacy. While Ibn al-Haytham is best known for his groundbreaking work in optics, his genius extended far beyond this single field. His contributions spanned a multitude of disciplines, showcasing his versatility and depth of understanding. He made significant contributions to astronomy, mathematics, engineering, and philosophy. His work in these areas laid the foundation for many modern scientific principles and methodologies. His writings on a wide range of subjects, from the nature of space and time to the principles of music, demonstrate the breadth of his knowledge and intellectual curiosity. He delved into the intricacies of the universe, exploring the fundamental questions that have intrigued humanity for centuries. He wrote over 200 books and treatises covering a vast array of subjects. Each of these works reflects his meticulous approach to research and his relentless pursuit of knowledge. His work on the movement of celestial bodies, the properties of shadows, and the principles of perspective had a lasting impact on these fields. His studies in these areas not only advanced scientific understanding, but also influenced artistic techniques and architectural designs. Furthermore, his philosophical writings explored the nature of knowledge, perception, and reality, influencing later thinkers in the Islamic world and Europe. His ideas on these subjects were revolutionary, prompting a deeper examination of how we perceive and understand the world around us. Section 8. Ibn al-Haytham's enduring impact. Ibn al-Haytham's influence on the development of science cannot be overstated. His contributions spanned various fields, including optics, mathematics, and astronomy. His seminal work, the Book of Optics, was translated into Latin in the 12th century. This translation made its way into European universities, where it became a cornerstone of scientific education for centuries. The profound impact of his work can be seen in the writings and experiments of later scientists. Roger Bacon, Leonardo da Vinci, Johannes Kepler, and Isaac Newton all drew inspiration from his pioneering studies. Ibn al-Haytham's emphasis on empirical observation and mathematical analysis was revolutionary. It laid the groundwork for what would later be known as the scientific method, a cornerstone of modern science. Even today, his ideas continue to be studied and celebrated. Scholars and scientists around the world recognize the enduring power of his scientific legacy. Often referred to as one of the pioneers of the scientific method, Ibn al-Haytham is a key figure in the history of optics. His meticulous approach to experimentation set new standards for scientific inquiry. His work continues to inspire scientists and scholars today. Modern researchers delve into his manuscripts, finding new insights and appreciating the depth of his contributions. His legacy as a brilliant mind and a pioneer of scientific thought remains secure. Monuments, plaques, and tributes around the world honor his contributions, ensuring that his name and work are remembered for generations to come. Section 9, a timeless inspiration. Ibn al-Haytham's story is a powerful reminder of the universality of scientific curiosity and the power of human reason. Born over 1,000 years ago in a distant land, his work transcended cultural and geographical boundaries to shape the course of scientific thought for centuries to come. His legacy serves as an inspiration to aspiring scientists and a testament to the enduring power of human curiosity and ingenuity. His story reminds us that the pursuit of knowledge is a timeless and universal endeavor. Ibn al-Haytham's life and work continue to inspire us to question, to explore, and to strive for a deeper understanding of the world around us.